Okay, time to start. Have you seen there's a home assignment? At Cyber University, there's a home assignment. So take a look and try to solve it as much as you can. So as a reminder from last time, we had a look into lists. We looked at them, how to arrange them, how to sort them. We can check their length. Right? We can reorder them from back to front. And we can make a nested list, right? So that is what we definitely looked at. And then we had an example of us building a nested list with an iteration that we executed manually. And then we used the indexing notation, the one with the square brackets, right, to access one level of a nested list, and then the next square bracket helped us to access the next level, and so on. There are also tuples. Right? So tuples only difference to list is that they cannot be changed. So the tuple itself we cannot change, but we can always override the variable. But this is different, right? So you really must access the element of the tuple, and those you can change. Okay, indexing notation. We have as well looked into tuples. Well, it works the same as with this. Now, this is new. This is what we have not done yet because it takes a little bit more time. Right, dictionaries. So dictionaries are a very, very useful data structure in Python because at least two values come in a pair. We have the so-called key and we have the so-called value. Now look at here at the little graphic I tried to draw many years ago. This is supposed to be a book. Okay, you open the book. Looks like this because it's a little bit curvy here, right? The pages are a little bit curvy. And then if you remember how a book used to look like, a dictionary, I don't know, I have a dictionary German to English. And then I would look for a German or a word in German. For example, I don't know, Hund. And then the dictionary tell me, hey, what is Hund in English? Oh, it's dog, right? So it's a mapping of one to one. Sometimes there are that are possible for one translation, but we come to that. So a dictionary in Python works a little bit similar to the dictionary in the real world. So we have one lookup value. For example, we want one as a word, and here would be one, right? That would be our key that we're looking up. And the value assigned to this key would be the numerical value, right? And then we could have a key and a value for every number. So 1 is the key written, and here's the key 2 written, right, as a word, but the numerical value is 2. We are not restricted to numbers or words. We can mix. We can have so here is it a Roman letter and a Greek letter. So A is mapped to alpha, B is mapped to beta, C is mapped to gamma. So far so good. So how is this useful? For example, you have a list of students. Every student has a name, and every student has a student ID, right? But when you write your exam, I'm not supposed to see your student name. You only write your student ID on it. And you have to keep your student ID for yourself. So I don't know which student is writing the exam. So you have the protection of anonymity. And so I am going to treat every student the same because I don't know to whom the student ID belongs to. If you don't keep your student ID a secret, then that is well, I know in Taiwan it's a little bit different, right? Everything is with your student ID, but in principle. And then the mapping of student ID to the name is actually a dictionary. Okay, and this dictionary you administration. There are many more applications. So I use dictionaries a lot in machine learning related tasks. If I have, for example, a string as information, I do not want to work with strings in machine learning. Right? I don't do that, simply like this. So I replace every string with a numerical value. Right? So I have an identifier, that is the number, and I can use the dictionary to map that value to my number efficiently. Okay, now syntax. Dictionaries are distinguished from lists and tuples via curly brackets and the use of the colon. Right, so now I'll tell you, actually, if you just use brackets, curly brackets, no colon, that's actually a set. Okay, let's see what we do. So here is the general syntax. Please, right, everybody pay attention for general syntax. If I ask you to write down a dictionary, right, then you have here dictionary, value, and key, value, key. I think now I was telling it differently, key and value anyhow. Here's an example. Dictionary 1 equal 1, 2 equal 2. Or the shorthand notation is just value 1 colon key 1, value 2 key 2, all in a curly bracket. Okay, so below is an example. This dictionary, this is the variable name, this dict short, and then you see the curly brackets. The brand is Ford, is Mustang, the year is 1964. So I think this example tells you about a car made by the manufacturer Ford. The model is a Mustang, it's a 1964 Mustang. It's supposed to be a very, it's a collector car, right? Okay. So far so good, right? Nothing very complicated. Just make sure you have two values separated by the colon, or everything in curly brackets. Program is the value. Okay. So there is also a shorter notation. Now in this notation, we have something very similar to a list comprehension. Just that, hey, we are using curly brackets. We have a key here. So this is an iterator, value n, because value n runs in the for statement over the iterator here, value n, in the range. This is my sequence that the iterator is running through. And the sequence here is made by range 6. So far, so good. And to pair now key and value, I must look at this expression here, right? So we have the iterator and then the expression that is supposed to be evaluated. So far, so good? A little bit complicated, right? So what do we do if something is complicated? We copy the code from the slides, for example, and then we create our own Jupyter notebook, and we play around with that piece of code a little bit. So here's my Jupyter notebook. I copy paste the code. This will not work right away, right? So I need to modify it a little bit. I keep it for my reference. So what do I have? I have curly brackets. Let me zoom in a little bit. I have curly brackets, right? And then I need an iterator. I need an expression separated by the colon. Well, iterator plus 100. Maybe not iterator n. So whatever value iterator has here, right? In the expression, so far so good? Good. And next, I just run the iterator over my range. Let's say 10. So what will happen? So in principle, it should start at 0 because the range gives you the values from 0 to whatever you put here minus 1. So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I should map 1 to 100. No, sorry, 0 to 100. 1 to 101. 2 to 102. Okay? Shall we try? Yes. Okay. So far, so good. Do you remember how we change a number to a character? I showed you that last time. So one was, I think one was odd. Was this for the number or for the character? Let's try. Nothing is working. Aha. So what is the opposite of odd? You see, I have the character A, and ORD changes this to the Unicode number. You also can ask odd what it's doing. It's doing something. Nope. What was the other one? So far so good. Do you see what happened? In odd, I put in the letter. I get the Unicode number. And in car, CHR, I call it car. I'm not sure how you pronounce it without a vowel. I put in the number. I get the letter, right? So far so good. So actually, this we should have a dictionary for this, right? From 0 to whatever letter we get at the end. So we can look up the values. So far so good. But now we can try this. We can make, hey, any idea how to do it? But we would need the iterator, right? Let's just call it I to be very sure. So I think is the most common iterator used in programming. Next to maybe J, K, L, and M. Something like this. Okay. So we have the number on the left. We put the colon to look up the dictionary for the Unicode character, right? And then we would say CHR. I again call it car. And then I just plug in the number. And that should give me the character. Okay? Now, which values should we run for? A is already 97, right? But A is the first letter in my alphabet. How many letters are in your alphabet? I think mine is 27 actually, a little bit more, depending on the right? But so we need to add at least 30 numbers or so, right? Approximately. Okay, so let's see what's happening here. So this is the expression, right, for the dictionary. Now we need to have this for statement. And the for statement always the same. You start with for, F-O-R, iterator I, right? So the iterator you put after for must be the same as the one you use. And then in. And then you provide a sequence, right? The sequence is like a list, a tuple, right? It's like server values. We can use a range. And so we are not really sure what car is doing, right? But we know there should be at least 97 plus user 26. Shall we try it? Okay. Okay, so funny. Do you know what's this one? So on your keyboard, there's a button called tab. /t is a tab. Okay? Try later. You know what is /n? It's a line break. Right? So you start a new line here. But there are no letters. No letters. What's going on here? So I need to scroll down. Oh, here are some funny symbols now. Can you see this? Finally, something that I see on my keyboard, right? So funny symbol, or maybe I shouldn't say funny symbol, but special symbol. Arithmetic symbols. Oh, then the numbers come. Do you see the numbers? Finally, numbers. Very good, very good, very good. Okay. And then more funny symbols. Letters. Letters. Very good. This is what we wanted to have. You see this from 65. Is it big enough? Capital A. And then so when I zoom in here, I can't scroll down for some reason. And we need a new mouse. And then until 90. So let's try to remember. 65 to 90 is Z. Okay? And then we scroll down. Here, 97 to... Oh, yeah, Z is here. 122. Okay. Let's try what the... So what did we say? 65, right? So when we skip out most of the funny symbols, and you see here, this alphabet also has 26 letters. Okay, so we have most of the, how's it called again? Characters, right? Letters. Very good. So what do we do with this now? We could say this is my Unicode. Execute, and then for Unicode, 65 was capital A, right? Unicode code. Get A. So the moment we have set up the dictionary, we can use it to look up values. We put in the value on the left, the number, and we get out the value on the right. So when we know, once we have defined key and value, we can look up their corresponding value. So far, so good? Easy, difficult? Maybe medium, huh? Okay, let's continue a little bit. No, this is not what I want this one. Okay. I have here other examples. In this dictionary, in this example, I have a dictionary of the squares of integers, right? So x is my value that I define to look up x, the value of x squared, and then I would have, well, I talk about it when we can just copy, paste it, right? Copy, paste, and I see what is in squares, right? So 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. So you basically can tabulate values. What else can we do with this? For example, we have a list of cities. Taipei, Kaohsiung, Tainan, Kaohsiung, Taipei, Taipei. Could be one column of a table where students are from, right? Okay. Or your neighbors or whoever. Or the breakfast you bought, where it was produced. So when we want, however, do some machine learning with it, as I mentioned, we would replace some form of machine learning, I should actually say. We would replace the cities, the strings, right, the words, with numerical values. So I can put, for example, Taipei 1, Kaohsiung 2, Tainan 3. So again, I have the key and value pairs. On one side the words, on the other side the numbers. If you want to put Tainan number 1, that is okay. Right? You can put anything, any number there, right? The important thing is that you have a consistent mapping of city to number, and do not assign two different cities to the same number. Okay, you can do it, but if later on, if you do some analysis or so, that might lead into trouble. Okay, let's see. So what do we do here? So in cities 2, we use our city dictionary. So we ask for the value that the iterator I carries of cities, right? And cities is over here. These are the words. So the first time I execute here the for expression, I has the value Taipei. Then it puts Taipei in my dictionary, right? And then it looks up the dictionary for Taipei and it puts a 1 here. That's why we get over here first element in cities 2 a 1. Then next one is Kaohsiung, right? It puts Kaohsiung in the iterator I. It plugs I into the dictionary city, and it sees, oh, Kaohsiung is 2, and it will return it 2. And it will do so for the next one, which is Tainan, right? It's a 3, then Kaohsiung is a 2 again, and then Taipei is a 1, and Taipei is a 1. So far, so good? Do you want to try it yourself? Because never ever trust, always reproduce, right? See if it really works. So I copy now line by line, I make it a little bit smaller, I close that help one. So I copy my cities, I check what is in cities. That seems correct, very good. I copy my dictionary, I paste my dictionary, I check what is in my dictionary. Yes, this one. Yeah, this one. Yes. Also correct. Very good. And then last one, cities 2. And I check what is in cities 2. Okay, that looks okay. Okay, but now I'm like, let's play around with this a little bit more, right? Because why not? So again, so this seems to work, but now I want to print what is in I actually to make sure that the dictionary works properly. So what I do is I put everything of my expression into square brackets, okay? Now the square brackets tell Python, hey, make a list. Right, so every iteration is now a list out of, actually I shouldn't use print, I should just use I. Out of the valued cities carries on the iterator and what the dictionary makes out of it. Okay? So now I have Taipei 1, Kaohsiung 2, Tainan 3. Yes, this seems correct. But if I can do this, I can even put I at the end, right? Oh, but this is now interesting because if you look carefully, actually, this is almost like a dictionary from 1 to the world, Taipei, from 2 to Kaohsiung, from 3 to Tainan, right? Because if you think about it, so you get the list of dictionaries, you make them numerical values. At some point, you want to reverse them back from your result back to human readable information. Huh, maybe we should do this as well. Actually, it's very simple. So we can just modify here the list comprehension to our creation of the dictionary, right? Let's see. We need to have a mapping from the dictionary values to the numbers. We have that here. But we don't want to run over cities, right? It's enough to just run over dictionary. Let's see. What do we know about the dictionary city? Yes. Has it a length? Well, we know there are 3 values inside. It has 3, right? So if we now say range over 3, we can use this, plug it in here instead of cities. And lastly, we need to change the comma from the list to the colon for the dictionary. Sorry, I need to push this button here. Dictionary from the shorthand notation, and this should do it. Sorry. +1. So what is the error? It says here somewhere there is no value of 0. Right? Our range starts at 0. You see this down here. It's 0 to 3. But we don't have this. Our dictionary starts at 1. So we must +1 here to find the key value correspondence. And then we need to 0, 1, 2, 3. Yeah, that should fine. No. I changed this quickly back. Right. So just now I actually overwrite my dictionary. And that's why I cannot do anything. Unbelievable. See you again. Dictionary is defined properly. No, I cannot see the issue. Let me just continue. And I look at it in the break again. Maybe I can fix it then. Okay, but in principle, reversing the values should be no problem. We can actually check again if it works. Putting it back into a list comprehension. No, something is more wrong on a more fundamental level. Cities is still working. I take this one back here. Sorry. Copy paste. Right, and we reproduce basically as much as we can from the example above because that is definitely working. So we have here, all right. Okay, so now I know what's wrong. The dictionary expects obviously a city. The city would be, for example, Tainan, right? And it gives me a number. What I try to do over here is to put in a number into the dictionary, which obviously does not work. So to fix it, very simple. I go here. I have an iterator and a value. I use enumerate, which I'll tell you later how it works. And I have my cities here in a list. I enumerate over them, and then I and J go here. Yes. And I need to make it a list comprehension. Okay. 1, 2, 3. Right. Enumerate. This is takes 2. Okay, again, we do it later. Let's see. So this is dictionaries. Yes. Now sets we had last time already, so we can go over them quickly. So in a set, I remember in math, right, we have set A out of 3 numbers, we have set B out of 3 numbers, we have an intersection, that's what they have in common, we have a union, that would be all the numbers, and then we have parts that are unique to A and parts that are unique to set B. There are no repetitions in sets, and we can use Python to easily get, for example, the intersection at A set dot intersection B set gives us what they have in common. That would be 2. We could have the difference. That would be what we have on the left. Please note the syntax. A dot difference B is we have now everything that is unique to A. If we want to have everything that is unique to B, then we would switch A and B around. So we would have B dot difference A and get everything that is unique to B. What else do we have? Union, that is everything. And then we can jump into the new stuff for today. That would be loops. So loops we have used already here and there because they are somewhat interlinked with our data structures in form of list comprehensions, as well as you can combine them with this definition of dictionaries as we just saw. So when do we use loops? We use loops if we have to do the same thing over and over again, so we repeat it, but changing only a small bit. Today, I showed you how to make a Unicode dictionary, right, to check up the numbers and characters. And the small thing we change is the value of our iterator, I. Right? We always add +1, we go to the next number. Look up the character, put it in our dictionary. Increase the iterator by 1. So we can do this in so-called for loops or while loops. Right? The for loops would run over the values of the sequence, and the while loop would run until a certain statement is not true anymore. So for the for loop, we have, does it do? Yes, only 1. Yes, no, for loop. So for the for loop, we have the general syntax outlined here. So for I and sequence, right? For is the keyword. I is the iterator that is running in our sequence or over our sequence, and then the expression is performed. Here's an example. Our sequence is a list with the values 1, 2, 4, 9. I runs over the values, right? And it says here j equals I times I, that is I squared. And then we print in the next command I and j. And we see we take I, 1, 2, 4, 9, right? 1, 2, 4, 9, and we form the squares of it, 1, 4, 16, 81. So far, so good? No? Okay, please also note that there again is a colon at the end of the loop head, indicating a new code block. So let's play around with this a little bit. So we take this, we plug it back here. Execute. So the first thing we observe is the code in the slides seem to work. But now we play around a little bit. So let's first play around with the indentation. So I removed now the indentation, the tab. Sorry, what will happen? So what is the change and why does it happen? So before I get this, I can even copy paste, it's very easy. And now we get that. What's the change? The difference is I don't see I1, 2, 4, I only see I9, right? And why? But the cause of this difference is somewhere here in line 3, right? So how do I read this? I read it like this. Oh, my for loop begins. My iterator is I. I start with I equal 1, right? Then, do the expression here, which is I squared, store the value in j, print I and j. Okay, I have this line. And then this is the end of my code block. I jump back into the top of my for loop. I is now 2. 2 times 2 is 4. I print 2 and 4. Next line, right? And I go this with 3. Sorry, the third part here, which is the value 4, right? There's a big difference. Okay, and then the 9 here. Good. So I print for I equal 4 and I equal 9. At the bottom, this example here now, a little bit different, but the result is very, very different. So careful. So here I read it like this. Oh, my for loop begins. My iterator runs over 1, 2, 4, 9. J is 1 times 1. It ends here, right? I go back. I is 2, J is 4. Oh, then the next one. I is 4, J is 16. And then I is 9. J is 9 times 9, 81. Print I and J. Okay? So the difference is here that the for loop runs in the hierarchical code structure given by the colon and the code indentation. In the first example, it includes the print statement, and in the second example, it only includes the arithmetic operation of multiplication, right? I and j. And when the for loop is done, when it ends at the end of my sequence, and when for loop is done, nothing to do anymore, then it executes print. Okay? And you handle this, right? This is very important. by the level of code indentations. So far, so good. Do you want to play around with it a little bit? Because what we can do is we always can add more level of code indentation, right? For, I don't know, J. No, we cannot use J, right? J already used before. Need another iterator. K, right? JK element, something like this. In 100, 101, and 102, right? Then we can say J plus equal K. So far, so good. And now look what, right. So what will happen? J will be much bigger, right? Sorry, forgot the colon, right? Much bigger. But if we shift now the print into the second for loop, then I execute I once and execute J 1, 2, 3 times, and every time I execute J, I print. Okay? Keep this one in mind. For every I print 1 J. Now I'm going to print 3. So I print I 3 times, and then I see how J becomes gradually bigger by add 100, add 101, and add 102. So far, so good? And again, I see this because the print command is here. Now, we can have more print commands just to follow the code, not to give results. We just want to understand the code, and that's what we do here with print. We have back our old print statement, right? But when I add now here, it's like, oh, this is very hard to see what's going on. So what can I do? Do you remember the Unicode table? Our /t/t/t, the tabs? So far, so good? So you know what's a tab in when you type your reports, right? Okay, this is tab, right? So I execute this print command 1, 2, 3, and then this inner for loop, right? The inner one is done. I jump out of it. Now the next one is this command here, print. But to distinguish this print from that print, right? The inner from the outer, I add a few tabs. So I see this one. Okay. If you don't trust me, we can we put a command sign in front of it to skip it, execute. We're only left with the one on the right. So far, so good? Okay. That's okay. That's okay. Questions? So take your time here a little bit. This example, again, I want to show you how a for loop works. I want to show you what's an iterator and what is the role of the sequence. And it's a reminder on using the correct hierarchy through the use of indentations in your code. It can make a big difference, and it can be a source of errors, right? Like logical errors that you must understand to solve. So far, so good. I would say then here we have a good time for a break, and I try to fix my dictionary example. How about that? Okay? Okay, good.